Hey everybody, this is Mr. Beckstrom, and today I'm going to be looking at section 10.3. This is number 4. This was requested in one of the forum posts. It says determine the foci and the equations of the asymptotes of the hyperbola, and sketch the graph of the hyperbola. All right, so let's go ahead and get working on this one here. So the first thing I like to do is, just like with all of these, is sketch this. But before I can really sketch this, I need to put this into the hyperbola form. And the hyperbola form is, this is one that's centered at the origin here. Notice that this will be centered at the origin because we're not adding or subtracting any single y values here, or single x values as well. So the formula is x squared over a squared. This is the formula where the x comes first, over a squared, minus y squared over b squared is equal to 1, where a squared plus b squared is equal to c squared. So we have this true here, a little where there. All right. So looking at this, I know I need to get this 2304 into a 1. So what I'm going to do is I'm just going to divide every term by 2304, which I can do. So divide by 2304, divide by 2304, and divide by 2304. And I'm going to use my calculator to give me the reduced fractions here. So calculator coming here. So this is going to be 1 here, but the other one's, that's 64 divided by 2304. All right, I get that, which converted to a fraction is 1 over 36. So when I put this into the form, this is going to be x squared over, we didn't do that one yet, but we just did the y squared one here. Y squared over 36 is equal to 1. And then I also need to do this one, 36 over 2304. So 36 divided by 2304, and convert that to a fraction. And that is 1 over 64. So this will be 64 here. All right. So now that I have it in my form, that I need it to, the first thing I have to decide is if this thing opens up or down or left and right. And because the x squared comes first, it opens along the horizontal x-axis, so that means this thing opens left and right. The next thing I can do is kind of find out where my intercepts are, so I can kind of plot those. And the intercepts are going to be, this is going to have x-intercepts because this thing opens left and right, and that's going to be at a0 and at negative a0. So to figure out my a, I know a squared is equal to 64. So just take the square root of both sides. A is equal to 8. And remember, we're only looking at the positive value of a because the formula here makes it negative for us. So that means at 8,0, and over here at negative 8,0, that's where we're going to have our intercepts here. And then it's going to kind of go something like this in both directions, right? And we don't exactly know, how steep or not steep it's going to be. That's why we're going to find out the equations of the asymptotes, because that'll help us figure out where these lines or these curves are approaching. So let's go ahead, but before we do that, it also asks us to find the foci. And the foci are going to be at C0, and this is x-intercept there, and this is foci. So it's going to be at C0 and at negative C0, negative C0. So for all of the hyperbolas, regardless of whether they open up or down or left or right, the A value is going to give you the intercepts. It'll be x-intercepts if it opens left and right, and it'll be y-intercepts if it opens up or down, so it'll look like 0A and 0 negative A. And the foci always use the C value. And what's the same thing with the foci. In order to get that C, I'm going to plug it in my formula over here. So C squared is equal to A squared, which is 64, plus B squared, which is 36. So C is going to be equal to the square root of 100, which is 10. Right? 36 plus 64 is 100. Take the square root of both sides, and we get 10. So the foci are going to be at, we're going to have one point right here, and this is at 10, 0. And we're going to have another point like right here. That's going to be at negative 10, 0. Negative 10, 0. So what in the world is this B for then? For the case of the hyperbola, the B is really only there to kind of help us graph these asymptotes. So if we go up B, so if B squared is 36, then B is equal to 6. So if I go up, 8 is a little bit less than 6. So if I go up, excuse me, 6 is a little bit less than 8. So if I go up 6 units up and 6 units down, so this value here is 0, 6. And this value here is 0, negative 6. If I do that, and then I make a rectangle with my B values and my A values. That's my B's and my intercepts there. So I just kind of make a rectangle. Let me do an inked shape here. Not perfect, but oh yeah, that's actually pretty bad. Let me do that one again. And so it should go like across, across. All right. Well, pretend that this goes through the x-intercepts and also B. This is what we're going to use to graph and to figure out our equations for the asymptotes of the hyperbola. And those asymptotes are going to go through the center here and also these corners. So we're going to have one that is, let me try to do this a little bit nice. So we're going to have one asymptote that's going to look like this. And then we're going to have another one that is going to look like this. All right. So these are not part of the curve. It just helps us graph these. This means that these curves will approach these asymptotes over here, and this curve on the left side will approach the asymptotes over here. So how do we find the formula? Well, we know that they go through the center, so we're going to use that point 0, 0. We also know they go through the corners, right? So that's going to be, this is up 6 and to the right 8. So this one here, so we'll call this one y1, y1, we'll call this one y2. So I know that y1 goes through the points 0, 0, and 8, 6. 8, 6. Now, what is the slope? Well, I can use the slope formula if I wanted to. That's y2 minus y1 over x2 minus x1. But we can just see it. If we start at the origin here, it's rise over run. So we're going up 6, and we're going over 8. So that's just going to be, and you'll figure out the same way, that's just going to be 6 over 8. It'll be positive because it's a positive slope, which is 3 over 4. All right, and then for the other one, it's going to go up 6 and to the left 8. So it's going to be that's M1. So M2 is just going to be negative 3 over 4. All right, so here's our two slopes for y1 and y2. Y1 has those points. I'm going to write, give myself a little bit more room. Y2 also has the point negative 8, 6, negative 8, 6. And then since I have a point and a slope, I'm just going to use the point slope formula for both of those. So for y1, I'm going to do it right here. It's going to be y minus y1 is equal to m times x minus x1. This means I need the slope here, and I need a point for x1 and y1 there. So for the first one here, it's just going to be y minus, and I'm going to use this point over here, or I could use the 0, 0. Let's just use the 0, 0. That'll probably make it a little bit easier. So y minus 0 is equal to, let me turn that into shape off, is equal to 3/4 x minus 0. And when I solve for that, I'm just going to get y equals 3/4 x, 3/4 x. Nice and easy. And then for the other one, for the y2, I'm going to do y minus y2 is equal to m, this is m1, this is m2, times x minus x2. So just put in the values for the second one here. So very similarly, I'm going to get y minus 0 because this line also goes through the origin, is equal to negative 3/4 x minus 0. We could have also used these other points too, but this is fine. And we're going to get y is equal to negative 3/4 x when we distribute that. All right, guys, so that's everything here. Just double check. A lot of work, but we sketched the graph, found the foci. Those are the 10, 0 and the negative 10, 0. We found the equations of the asymptotes of the hyperbola, and we are good. So if y'all have any questions, let me know, and I hope y'all have a great rest of your week. Thanks.